Let me see if we are. I don't think we.
Is my microphone bad?
Oh, now we are. Uh, well, it's okay for me.
No, but it is worse than usual, right?
I don't think so.
It is exactly the same, are you sure?
Well, of course, I'm not 100% sure.
Do I seem distant from the mic?
Uh, wait. I don't think so. Like, I can hear you just fine.
It's because my headset, for some random reason, the microphone is breaking by itself naturally. I don't know what's happening.
Entropy? I don't know.
I'm gonna have to buy a new headset, man. I'm so mad, but okay.
Yeah, but we are on it. Like, and we have.
Okay.
Oh, wait, just a second. Ah, that is a. Wait, what the fuck?
What?
Wait, what?
What you talking about?
Ah, I guess we have some bots here. Like, if you, I'm, I'm in Twitch, and then you have like a way to see like all the viewers, right?
Mm-hmm.
And well, there is me and some like three other people, but I think they are bots.
Yeah, it doesn't make sense to not be bots. I agree. If they are not, if you're not a bot, just say something in the chat.
No, I'm pretty sure they are. You can even like, yeah, they are.
Okay, cool then. Okay, so the types, man. The types are these ones.
Wait, I cannot quit.
Oh, we
Okay,
need to make the refresh function at some point as well. I forgot about that. Okay.
yeah.
Okay, so
Wait, do the what?
we need to make we need
Oh,
to make the
refresh function.
refresh function.
Oh yeah.
uh,
Or you can just ask the user to not use like clashing names, like only use unique identifier.
okay, declaration. This is the type that we made last time.
Okay. Yeah. Ah, yeah. Well, that is something that we will need to think about, like for the future regarding the parsing tree. But for now, let's just ignore that. Let's just do like straight
Okay, I
alias.
also did the parsing for that, as far as I remember. So there is declarations up here,
Oh,
and
parse for declaration, right?
and these are the parsers that we have for declarations. So we have one for functions and another one for, and then we just
Yeah,
have the one for expressions.
yeah. Yeah, that's not quite what I'm talking about, but let's go back to the types there. Okay, so declaration, right? Is either a declare expression that is just an expression, okay, or a declare func, right? Text. What is the maybe type? Is that the type annotation?
For the return type, yes.
Or the return type? That doesn't make sense. Uh, yeah. So this is our EST, right? So this is like a declaration, not a declaration function, I guess.
No, it
Uh,
is a declaration because we're also gonna have declaration of values, I guess.
no, they will be the same thing. Like they are the same node.
I don't think they are, but okay, go on.
Try to make the reason why.
Because if you are a declarative value, your kind at the end needs to be star, and your type needs to be a literal. And if you are a function,
Wait. Go slower on that. And repeat again, please.
if you are declaring a value, we need to
Okay.
check if the thing that you're declaring is a literal or not.
Wait, if it's literal or not? I could do a lambda, right? And
No,
that's
then
not a
it's not a
literal.
def value. It is a def fun.
No, that's a. Wait, just a sec. I can do like this in Haskell.
No, but we already agreed on making the separation of functions and values. Yeah, in
Like
Haskell
the
you can do
user
that.
can, yeah, the user can always do that because lambda is an expression. If I let you do an expression to a name, you can always do that.
Oh, but that then I don't see the point of having separate names then.
What do you mean by separate names?
Yeah, we were discussing about having def fun and having def value.
Okay.
So what is the point of
Yeah.
having true if you can make whatever in def fun?
The fun is so much easier to write a function with multiple arguments. How would
That's a
you
bad
write?
reason to argue, but okay.
Well, then why do you have this in Haskell?
What do you mean?
Take a look on the chat.
Oh, those are the same in Haskell.
No, but why do you have the second syntax if you can just do it in the first?
Well, because the second you can do pattern matching more easily.
It's just because of the pattern matching then.
Yeah,
No,
okay.
no, you are talking about a different thing. You
Yeah,
are
but
talking
what I
about
am
top
talking about.
level pattern matching.
Yeah, that is why Haskell has the second way.
No, it is not. Like, okay, so Okama, right? So what about this in Okama? Like, Okama doesn't have like top level pattern matching. Like, why would Okama do that if I could just do what the Lambda?
Well,
Like,
then the
let
only
me.
reason I can see is what you said. It is easier.
Yeah, man, that's fine.
No, but that's not what we are talking about. We are
Okay, can
talking
you?
about are we gonna have separate values and functions, or they can all be done with something with one?
Oh, okay. I think I got the part that we are like having a mismatch here.
Yeah.
You're talking about parsing. I'm talking about AST. If you have both or not in the parsing, doesn't matter. The node will be only one. They will
Can you
both
repeat
like,
that?
yeah. Uh, Even if you have the fun and that value like separately and they are very different and parsing and stuff, they will result in the same node of declaration data type.
Mm. Okay, that I can agree with.
Yeah, so that's why we only need one, right? There. Declaration that, okay. Yeah, then now we need to talk about this navy type. Like if you want that, that would be a notation for the
For the function itself. I think no, wait, no, not for the function. It is under
for the
type
binding,
annotation for the
right?
function. It's the return only.
Uh, Wait, but doesn't make sense when it's a value because a value doesn't have, right?
No, that
Wait,
makes sense if it is a value. What do you mean?
wait, give me a second.
Value, um, something, integer, true.
Okay, so that values something. And what the fuck is that sync?
That is the current syntax.
Okay.
Well, we can
Okay,
change that,
so
but that's fine.
that's for the value, right? And now give me the defunct.
Okay. So the defun is function. No, wait.
Yeah, that's nice. Yeah. Um, I mean, we have such a cursed syntax. Why do we have equals inside X expression? Like,
Oh, you mean this equals at the end here?
yeah,
I
but
don't
that's
remember
okay.
if we added that or not. Let me double check in the examples. No. This seems wrong. Fun. Oh,
Okay.
here.
Uh,
We don't, actually. We don't have that what I said. It is oh, it is not here. We don't have this.
no, that is no. Wait. Wait. Can we even? parse that?
Yeah, you already parsed this, by the way.
Dude, that is something. That is something really weird. On we just have the type and then the next expression, like and no separation.
We have a separation. It's called a space.
No, dude, that is. Okay, let's not see this now. But
No, no,
okay,
no. But this thing here that I showed you, this we are already parsing this.
well, then that's okay. Yeah, and it really doesn't have. What the fuck? Okay, but that's not a problem. Uh, so you see that if you go into the expression and if you take a look on the abstraction, it already has a maybe type.
Yeah, when we parse this, we are converting this to this. We are
Yeah,
converting this to
so
this. Sorry.
you so yeah, dude, why would we need this maybe type there if you already have on the abstraction?
That's a good question. I actually don't remember what we are doing with that.
Like if that's the return type, then it doesn't make much sense because well, the abstraction would already have.
Let's see.
Wait, what do you mean by let's see?
Why? Why not?
No, no, how will you see that?
We're gonna parse it and see
Oh,
what
okay,
we
some
do.
things are implemented and you see what it's
Yes.
doing, right? Oh. Yeah, maybe we have a problem regarding Twitch chat. Like, I don't think no one will come, but if they do, maybe I would not see their messages because Twitch is really trash. Like, the chat keeps like disconnecting. So yeah.
Oh, that's great. Wait, is this the one that I killed at the end? I remember killing a line. No, it isn't here, in fact. Hmm. All of these are working just fine. Something. Oh no, flush is being called here. That's okay. Well, we don't need to care about this at this point. I think you are right about having redundancy.
Well, if you want something to be there, then it could be your. Oh, that's interesting. That's very, very interesting. So yeah, if we would have something there, it would be like a notation, right, for the binding.
What do you mean notation for the binding?
Uh, like this,
Oh, having. No, wait. I don't know what to do.
like this, I guess. Maybe I even forgot how to write token. It has been a while since I code anything.
Wait, isn't that what I showed it before?
I don't know what you showed before.
Oh, that's cool.
You mean
Uh,
that value?
yes.
Yeah, yeah, yeah.
Okay,
Uh,
so wait.
what I'm saying is the following. First of all, you don't need type annotations on declarations. You don't. But if you want one, right, then it would be a maybe there. But then we would have something weird because the normal bind, like the value, it can have one. But function, the function doesn't need one type annotation because it
Oh,
already has
I
type
know why
annotation
it didn't
everywhere.
work, man. I know why. It is because I set the parser to try to parse expressions, not declarations. That's why. So that means that in order to make that back to work, sorry to interrupt you, but I kept thinking about it. Uh, in order to make that work, we need to go into here, and instead of expressions, no, not this one, actually, this one. expression P, instead of expression P, we put declaration P. And that will work just fine.
Yeah, it's no, that's not okay. It's not declaration P. It's like a
No,
list of declaration, right?
no, it is a list of declarations, but I'm in this. I'm not. You're correct. You're correct. Let's put declarations here. Declarations. Yes. That's why. Wait, now the types will break because I removed them maybe.
Lemos, what usually happens in the language when you try to like run an empty file?
What do you mean?
Like, what happens if you ask GHC to compile an empty file?
I have no idea.
Like, just for us to know if it's a many or many one, right?
Yeah. Mini type. Um, oh, I put it backwards. No, I didn't. Name. And this would be the type. That I'm just not gonna care at the moment. I want to see what we did what I did when I was implementing this the first time. But to be fair, I did with Magenta, not the parser. No, the parser itself I did with Magenta. Okay, now it's gonna compile just fine. Oh, I know why that failed. It's because this is not ready to be a list of expressions yet. Oh, it's because of the type checking. That's why we didn't do it.
I see all those all those parentheses in the case of like Commander and Magenta. I think I'm tired of this programming thing, man. I don't think I want to do this anymore.
Wait, you mean what exactly?
I think I'm quitting programming, man.
There's no way you're doing that.
I don't know, something about all those all those parentheses and arrows. I think I'm tired of this shit, man.
What do you mean, man? Anyway, let's go back to the point. So, I remember now why we didn't do that way. It's because you need to
Which
have
way?
expressions because the type. Yeah, why I am parsing expressions and not declarations? Because the type checking is not ready for declarations yet.
Mm, okay.
So that's why. Okay, so what we were talking about before? Oh, we were talking about having or not having the maybe in the node itself.
Mhm.
Okay, so what do you have? Did you say again?
Okay, so for the normal bindings, makes sense to have well, not well, it could make sense to have a type annotation, right, for the values.
Yes.
But for the function, it it really doesn't, right? Well, yeah, I guess it doesn't.
Yeah, it doesn't because the E abstraction already has one.
Not only that, but we don't even have a syntax for that. Like, how do you put the type of your parameters, the type of your return, and the type of the whole thing itself? Like, you don't even have a syntax for that. Like, languages usually don't.
No. But when we added the maybe, that would be the same maybe as the abstraction, I guess. That's why I wanted to see the how we parsed it.
Would be the same.
Actually, I don't know
Yeah,
why.
then would make no sense because then it would be the return, but it's supposed to be a notation, right?
Just a sec. Yeah, it is the same. It is the same as the abstraction. It is appearing twice, here and here. It is the same.
Yeah, that doesn't make sense.
I agree.
Uh, so yeah, let's just remove entirely, and in the future, if you want to add, we like separate into nodes and do stuff.
Okay, yes.
That way it's simple, right? I think we are done with our declaration data type. It is that simple, man.
It is that simple.
Yeah, let's type check this shit now. It's also like everything ridiculous simple also to type check and evaluate those things.
Really?
Yeah.
I'm very interested on that. Let's do it then. So that is equal to
It's
that.
really fucking easy until it's not, right?
Okay, typer. So what do we need to do in this guy?
A function to type or
I think this guy needs to change significantly with this guy. I may be wrong
no,
though.
it's a different function. Uh, that function is to type expressions. So what these you do is just receive the list of declarations and return an error or not. I guess. Like it doesn't really return a value.
It returned what?
It really doesn't return a value. I guess it's a maybe string, right?
What is the maybe for?
Like it is either an error or not. All right. I guess I don't know. Mm.
Okay, we can also do
Uh,
something though. We can also replace string. We can replace type check with environment.
yeah, I guess it takes also the environment, right? Because
That's fine. We're gonna replace that with type check expression.
by the way, that's the part that I think I never did on my stuff, like the declaration part.
That's cool.
That would be nice.
Okay, so it's gonna also receive a typer env. What is the? Is that correct?
Yes, I guess so.
Okay, so type
Let's
check
do it.
declaration. So if you receive this, then it's gonna be a nothing, I guess. The maybe is for an error, right?
Yeah.
Okay, so this is nothing. Type check.
So in theory, that should not happen, right? Like,
Yeah, in theory the parser shouldn't allow that to happen, but
okay.
env. I guess we can also do typer env here to have the other stuff, and then we're gonna have a list here. Okay, so what do we do?
Yeah. Uh, I guess you don't need to do structure the list of declarations, and we just do a fold, of course.
We just do a fold, of course.
Of course.
This fold will do what?
It will fold the declarations and type checking them.
But if it is an expression, you're gonna have an either, right?
Huh?
Yeah, because an expression, when you type check an expression, you get back an either.
Okay. Then.
Then it can't be a normal fold. It needs to be a special
Oh.
fold.
Okay, I see. Like your for or fold M, right? Okay, fold M is the one that you could be passing stuff, right?
What do you mean?
Like the normal for, you cannot pass stuff, right?
Yeah, you cannot do monadic stuff like maybes and either. See here? This
Yeah,
type
yeah.
signature?
Yeah, not that I will understand this right now, but let's go.
Well, the function that you're folding produces something. A maybe, an either.
Oh, okay, and then, oh, I see. So
Um,
let us go.
okay, I am kind of worried actually about...
Although,
Oh no, we can convert. We can convert.
we can,
That's cool.
what do you mean?
I don't know
That
how...
was the thing you were worried about? Like, if it's a fail, so we can convert it to a string?
Actually, this is not that, right? This is grabbing the right and transforming to a maybe. The logic is reversed in our stuff.
Oh, okay.
That's interesting, but that's fine.
But it's like one pattern matching more, like, doesn't...
Okay. So what is going to be the initial value of this float?
The env, I guess.
The env. Okay, so this is actually not a maybe. This is either an error or an env.
No, it is not.
Well, we're gonna return an env, right? If it, the
The
env
fold
updated.
will, but not the type check declaration. Why do we want this env for?
Well, to
Oh
pass.
wait, no. Oh wait, yeah, maybe we do. Maybe we do. Ah. Okay, but then we are thinking about like multiple files and stuff, right?
Yeah.
Yeah. Why does anyone needs more than one file to write code, man? Like, what's the sense of that?
You're losing it. You're losing it, but okay.
Okay, let's just return the type env. Wait, result t?
Yeah, it's already hard coded in either T as a type alias.
But what the fuck is either t hard-coded true, like the second one, the fail case? The string?
A text.
Wait, you done that or
Yeah, it's the
is that
same as
from?
a type check expression, man. Look.
Okay. Yeah. So let's return this env, right? Like maybe we need that.
Oh man,
Maybe.
you're not only getting away from programming, you're getting crazier.
What do you mean with that? Okay. Uh, so yeah, that's the list, right? Instead of env there. Like, isn't env the last argument or? Oh, okay. The last one is the list, right? Yeah.
Yeah.
So just pass the list.
Okay. Now
Where fun.
we need to define the fun function. This fun receives the accumulator, which is going to be the env. It receives also a declaration and needs to return an either. Okay.
Okay. So let's.
So I guess that if this is an expression, then it's easy.
It is easy.
We just call type check expression. We pass the accumulator for it.
Why are we calling this accumulator?
Well, we can call it any.
But let's go.
Oh wait,
Mm-hmm.
that's a problem, my man.
What is the problem?
The problem is the type check expression returns a type.
Yeah. So what?
And we need that, and we need to have actually the type environment.
Huh?
Yeah. You see the difference here on the types?
Easy. Okay. So let's first go with the expression. The expression, you don't need to worry about any of that. You will type check if it's unit.
Yeah.
If it is, you just return the same env. Otherwise, you give a warning if it's not unit, I guess.
Wait, your idea is to type check this guy?
Yeah.
Type check this guy. If it is something other than unit,
Then you just return the env, I guess.
wait. So this is t unit.
Don't you have a case that does the denotation plus case at the same time?
Don't you have
Is
a
there
case?
something like a do case?
I don't know what you're talking about.
Like, imagine something like do case and you put an expression that you already like you do the arrow to the left and then you do a case, right? Like, is that a way to like
Not
do
that I am
both at the
aware.
same? Okay, but let's go on.
Yeah,
Oh, by the way, I have some meeting today at like midnight, man.
Oh, for the new job stuff?
Yeah.
No, that's awesome.
I don't know if
That's
it's
awesome.
awesome
You're not
at
gonna sleep
midnight.
anyway. You're not gonna sleep anyway. Who fucking cares?
Okay, that's fair. That's fair.
Who
Uh,
fucking cares?
so
Let's throw
yeah,
an
if
error
it's
here.
not, oh, show
Uh,
it. Okay.
de declaration erro. Uh,
I don't think you.
no declarations found to type check. Okay. If you have this, then you're gonna return the env. That's cool. And then if you have anything else, then you're gonna throw an error.
Yeah. Uh, then that's the thing. You will not.
Oh, really?
Yeah, that's a warning, right? So the program still like goes on. So how do you do that, man? Haskell.
Oh, there is an alternative for that.
I don't know what it is.
Nesting
Like,
ethers.
wait, that sounds like a bad. But can you explain me what you want to do exactly?
Yeah, instead of this, you do that.
Dude, dude, that doesn't look healthy. Uh,
Well, to do what you want, this is what you gotta do.
no, no, no way. There is no way you cannot do better. We cannot do better than that.
I don't know what's the problem, but okay.
Dude, that looks really bad.
Well, how can you want to return three things? An error, a
No, no,
warning?
that doesn't work. You know why? Because it has to be both. Like we need type and text. So it would be like a turbo of type and maybe text.
um,
Oh,
okay.
God. No, 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 no. I'm not saying we should do that. I'm saying that's a crazy way to do it. What about no warnings today? And we just write a comment about
Okay, I think we're never gonna do warnings then, but okay.
it. Like
Uh,
it's not a huge deal, right?
uh,
Uh, Not if they're returning. If they're type R, right? Oh, okay, returning from a type checking, yeah, but yeah, that's okay. Uh,
um,
yeah, then any case you don't need to pattern match. You just like return the end.
oh, you're not gonna have to parameter, you're correct. No, actually, if we don't want to have the warnings, we can consider them errors.
No, no, but that's bad because you should not have an error for that, I guess.
Well, we should have a warning, but we don't. You're not implementing the warning at the moment.
Man,
Then,
if you're not doing a warning, then it's better to not have anything than having a like an error when it should not be an error. Like
okay, so it's always return env, I guess.
yeah, and we can just ignore the type, right?
Well, if that's the case, we can do even better then.
Like bind them. Yeah. Oh, the bind with ignore. Oh, nice. Nice, nice, nice. What is it complaining about?
No, I don't know what he's complaining about at the moment.
Oh, it was because of exhaustiveness on fun, I guess.
Um,
Okay, so we were talking about some problem. I don't remember.
no, we don't. No, I don't. I don't remember anymore what would be the problem. But
Well, let's go. Let's like match.
okay,
Wait, match what?
I guess these would be like this, and this is gonna be like this actually.
Wait, wait, wait. Where is our? No, no, we don't need to destruct any.
We need
Do
to.
we?
I think we
Oh
need.
yeah, because we are going to add stuff. Yeah.
So this is
Wait,
gonna
but you
be.
have two things inside declared def. Like you have a name, I guess.
Wait, I'm confused. What are you talking about?
Declaration definition has a name also, right?
Oh,
Like a
it's a
name and
name and
expression.
an expression. Sorry for that.
Oh, okay.
Uh, okay, so then this is a do notation again, I guess. Because we need to type
Easy.
check the body. We type check the body.
Oh yeah, that's inside the lambda that's going to the fold. Okay.
Oh, actually, it's kind of the same thing because we don't care about the type at the moment. So,
What?
do we care about the type of the expression in the body?
Sure. Wait, body?
Yeah, the body of the function, the definition that we are doing.
Oh yeah, sure we do. That needs to go into the env, right?
No. Wait. Oh, you're correct. You're correct. Sorry. So we do care about it. So then it's gonna be return of the same environment, but updating the variable types with map.insert, and then the key is going to be the name, and the values is going to be the type, which is going to be type prime, and the map that we're going to use is going to be variable types as well. Okay. Declare but not used. What are you
Return
proposing, my man?
ACC. Wait, what are you doing there? What is this ACC? And then you have the record syntax. Like,
Yeah, so this is picking this record. It is going to this field here and updating with this.
wait, what?
Yeah.
Oh, so that's ACC, but with variable types updated?
Yes.
Well, that's quite a syntax, man. Uh, yeah, then I think that's what you want, right? Are you
Yes.
lagging something?
I don't, we are lagging just the foldem to be here. Control.monet.
What do you mean for them to be here? Oh, okay. Part. Like, is everything type check? I know I said it will be simple, but I'm guessing we are forgetting something, aren't we? Uh, like, we type check, it has a name, it goes into the end to the next stuff, the next declaration. Yeah, I suppose it's right. But it feels weird, I don't know.
But it
None,
feels weird, you
yeah,
say.
don't ask me why, but yeah, I think we are done with that then.
Okay,
So you see, just a few lines.
just a few lines. What about evaluation then?
Also easy, I
Also
guess.
easy, you say.
It's literally the same thing, but well, evaluating. As you
Wait,
can copy
do
and
we
paste it.
actually? Oh no, we do need. We do need.
Are you proposing one single function to the evaluation and type checking?
No, I'm not proposing that. I was thinking, okay, why do we need to change the evaluator? Because the eval environment it will be updated, but it's not going to be updated because our thing is text to values, and the environment that we did was text to types. So we actually do need to have it here. So let's do that.
Yeah, but it's pretty much a copy of the same things, like with well, evaluating instead of checking, right?
Okay, first things first. Let's replace eval with environment with eval expression. Second is to paste this That's super cool. And we don't need this thing. And we actually don't need to dismember this thing because this thing is only one thing. This will be evolve. This will be evolve. Okay.
Wait, are we done? Holy. We just evaluate the thing and return the environment. If it's a thing, we just yeah, you have the name type there.
Oh yeah, we do have type here.
So we are bald expression. We insert into the map and go to the rest. Man, why is that feeling of something's off?
No, we still need to update the prelude, I guess, because I changed the name of the function eval with environment. So let's do that. Oops.
What? I don't know what you mean.
We need this guy.
Oh, okay, yeah. We don't have these like type checking and eval like expressions with the default thing, right?
No, we need to change the name of the function, that's all.
No, not only name. There are functions that we need to exclude them.
Functions
We
that we need
had,
to exclude.
yeah.
I'm
Do you
confused.
remember that we had like two functions? One for evaluating an expression and the other for evaluating an expression, but doesn't need an if.
I don't remember anything of that, I'm sorry.
Don't we have like eval and eval with environment?
Yeah.
So what is the difference of those?
None.
What do you mean by none?
It's literally none, look.
But we had the eval with environment that like would already have the prelude as default, didn't we?
No.
Well,
Oh,
then
we
that's
changed that because now we were doing that back in the day, but then I changed it to this.
okay. So yeah, then we are fine already.
Okay, so let's test this thing out. So we need to go to here and change now. So how that's gonna work? So these, instead of expressions, we're gonna do declarations. Right? Then things will broke immediately, I guess. So these are declares.
Oh,
Oops.
okay. The repo is a different thing, right?
Yeah, the
Like when we
repo
are
is
not in the
different.
repo, we don't need to return like type for stuff, right? Or even values for stuff. We
No, we
just
should
run the
return
side
values for stuff.
effects.
We should return values for stuff.
Ah, that doesn't make sense, I guess. I don't think we can even do that with our code right now. Like binaries don't generate values. The only ones that generate values are the ones that are just expressions. And yeah, we don't want those values. We only want the side effects.
Wait a second, man. We made the functions to receive lists of declarations.
Yeah.
Um,
Oh, parse declaration, like declarations will give you a list of declarations, right? You type check if everything is okay, then you evolve.
yeah, no, I know what you mean, but I'm thinking I need to remove stuff because I was doing the list stuff with the for. We don't need that anymore. So this goes away. Uh, all these guys are fine. Uh, yeah, these are also fine. Then we ignore this. This is gonna be then the type environment, I guess. Yeah, this what we're ignoring here is the type environment. Then we call the same thing, but with
What the fuck is
declares.
TIO, Lemos?
What?
What the fuck is TIO, man?
Oh, it is a It is a package specifically to not have to do packing and unpacking all the time.
Oh, that's interesting.
Okay. We have this. Okay, that's cool. Variable not in scope. Declares. Oh, here.
The S.
Yeah, variable not in scope. So I probably need to export this at some point. So type check. Is the typer exporting this for us?
And
No,
also, where is the prelude, right?
Declarations. This needs to be in plural, by the way. And this guy also. Oh, that's why we were having problems there. Okay, so evolve declarations. And this function also makes sense to have an S. I don't know if Emacs will update automatically for me. Probably not. Variable not in scope still. I have no idea what he's talking about. Because I am importing the evaluator here, and I am importing the typer, and I don't have the lists here, as you can see. So I think this is just Emacs going crazy, so I don't really
What
care.
is CL?
CL is for the command line stuff, is to parse the command line stuff.
Oh.
Okay, so I think we are ready to test.
Wait, what is the prelude?
Here.
For the type checking?
For the type checking. Oh, we don't have it here. The type checking was using the previous strategy that you described. Here.
What?
Not here. Here. We don't have a reason for it though, so I'm gonna just remove it.
We don't have a reason. That would be a problem.
What? Wait, sorry?
That would be a problem.
Wait, should we have something like this?
No, we shouldn't.
We shouldn't. Why?
Yeah, because we need to receive the env on the type check declaration stuff.
No, but we would. That's fine.
Okay, but I don't think we are passing that, right? Wait, what is that? And typer in? Typer prelude? Map empty?
Yeah, an empty map in the beginning, yeah.
Wait, why do we need a map empty there? On the...
No, this is the begin. This is the. Oh, this is the kind one.
What?
Yeah, this is for type variables and stuff.
Oh, okay, you have two oh, I see.
Yeah. Okay, so I think we are ready. We are ready to test. We are ready to test.
Yeah, try to type check that. I'm not very confident.
I am also not very confident, but that's fine. One by one. Let's go slowly. Okay. Okay. This is totally fair.
When does the type check gives you a error that is not fair, Lemon?
Well, when I don't know what it means. When it's very complicated.
It doesn't mean it's not fair. It only means you don't know shit. Imagine that in real life. Someone is talking something that I don't know about. It's not fair.
Yeah, it's not fair. It's exactly when you were, I don't know, Rust stuff and you have like
So take a look on the
lines.
following scenario. You do something illegal, then the cops come to arrest you. And then you ask them, oh, but what did I did wrong? And then they said, but you didn't understood. And then you say, oh, then it's not fair for you to arrest me.
Yeah, that's fine.
What the fuck, man?
That's
That's
fine.
not how it works.
That's fine.
That's fine?
Yeah.
Dude, that's a problem.
That's so.
Yeah.
Oh man, it's gonna be so. I don't want to fix this right now. Okay, so let's do like this.
Fix what?
Um, fancy command line stuff.
Oh.
93 do. Oh, this is an empty block now. Um, 40 true. Oh, this is also wrong. Why can't we have the embedded, like a type check function that has this already? I don't see a reason why
Ah.
not.
Okay. We can. We just want to use it in the type check declaration.
Oh,
Because I see you want it for the repo, right?
yeah.
Ah. Wait. But even the dude,
What?
I think we have a pad of a really like huge flaw in our repo. When you declare something.
We don't declare things in
Oh,
our repo yet.
oh, okay.
You don't declare stuff yet. What are you talking about?
Okay, let's just like comment out the repo for now because we will have to do stuff there also, I guess.
Yeah. Okay, so let's
Because
comment
the repo needs
this.
to have the ability of like do declarations, right?
Yes, it does have. It does need that ability. Yeah.
Yeah, let's comment it for now.
In the
Print message.
36. This is up there. Oh God. Okay. We do have a problem though.
I bet we did.
Um. Okay, so let's not do that at the moment. Let's just do, I don't know, print. It worked.
Oh, were you printing the type?
I was printing the result. We don't return the result anymore though. We return the environment.
Yeah,
It worked.
it worked.
Yeah. So let's try.
You already have the files, right?
Yeah. Wait.
Do you have the parsing for everything?
Yes. We don't need these anymore.
Maybe what is not correct is the mapping of the parsing.
I do believe it is correct. Take a look.
Ah, da. Man, I can't read shit. Can you explain?
Yes. So what is a declaration? A declaration is a definition of a function, or it is an expression that we're just wrapping with a new shell. Let's say.
Wait, does your... Oh, then we have a problem, right? We don't have the def value.
Oh, not yet, but that's not important at the moment. We will make a def value shortly, but not now.
Okay.
Okay, so I want to see fun.sw. It is a problem in the parsing. That's cool. So probably. Oh, it's here.
Oh, do you have this? Wait, what is the most? Yeah, what is the most high level pointer that we are using as entry point?
It is this one. So
The
you,
declarations P, right?
yeah. So you open a bracket, then you have def fun. We can add like more freedom to the user having
We can even
spaces.
call this a file, right? Declarations P.
Yeah, we can call this a file. Why not?
That makes sense. The end of file.
Oh, this is the entry point. Yeah. So you have a bunch of spaces between many declarations spaced with spaces, and then you have the end of file here.
Nice, that's really nice.
And then each declaration, it is an expression or a definition of a function, which will be the value in the future. We'll make that happen.
Okay.
Then you open a bracket, then you type def fun, surrounded by spaces if you want.
Yeah, not that interesting, that one.
Then you give the name of the function. Then you put for us the couple of parameters in their types. Then you put the body, and then you close the bracket.
I still think it's such a shame we don't use the. Gosh, I'm not programming in a while.
It's such a shame that you're not using what?
The thing that is not the bind.
Oh, the applicative.
Applicative, yes.
No, we can make that happen. That's not hard.
In the future, if I have the courage, I will do a proposal of refactor for
Yeah,
you.
but you say that all the time, and I want to believe in you, but that's hard. Because you said that I think 3 times already.
Okay, so don't you believe that I will actually do it, or that is actually possible?
No, it is totally possible. I would do it if I had the time and the courage and the energy.
Okay.
Anyway, this is not that fun. Let's just build again and see if we have a problem now. We do have a problem now because I changed the name of the parser. File. Imagine having multiple files, man. We're gonna have to do.
Well, we will, right?
Yeah, but we're gonna have to do like.
And then they have a new declaration, right? The open declaration or import declaration or something.
Yeah. It's gonna be really, really interesting.
I hope we go with something simple, man, because yeah.
Emacs is totally crazy down there. Okay.
It looks like it works. Yeah, but are you doing side effects? Because we have no way to.
We need.
To
Yeah, now
the...
we do need to make a side effect. So let's create. Let's do a print. Right. Let's do a print.
By the way, the values, you can just do something that receives unit and returns the value.
No, I want to use the function ABC, man.
No, I mean, if you want to declare a list to use in multiple expressions, you can do that. Please. You don't really need to pass those types to print and stuff.
Yeah, we do because don't have type inference yet.
No, that's what I'm asking is, do we need to receive this at all? Like, it's not that if it's taken right now, but is if we need to receive that for some reason. Like,
I don't know what you mean. Can you explain a little bit more?
go on. Give me a second to think about it.
Okay. Oh. Type is matched between parameter of type integer to inches and argument of type integer. Okay, so we do need to make like this. It worked. Two plus one. Yeah, it worked.
Yeah, I guess we cannot do without type inference as you said.
Okay. We have the funds. You can define your own functions that do stuff. That's super cool.
Do more stuff, like do another line printing the same thing but mapping before or something. Like print something different in another line, right?
Wait, where? Where do you mean?
Just print something else. Like I want more than one line printing stuff.
Oh, okay. print bool t. Yeah,
Yeah. Wait.
it worked.
Um.
Those
Um.
sounds of thought process.
Wait. Wait. That is something weird. Uh. First of all, should those things be quoted? I don't think so.
I do believe they should be quoted. Why not?
Because a string will appear as quoted. Wait. Wait. Uh.
Well, I think it is possible to remove those, by the way. But let's see. Um, it is in the. I don't recall.
Okay.
Expression? No, expression has
Actually,
this.
I think that everything should appear unquoted unless you have a string that is escaped inside. Well, unless that you have a double quote that is escaped inside a string. I think that's how Haskell does, for example, right? And other languages.
That may be a problem then. Because
What is
I'm
the
not
problem?
adding the quotes by myself.
What do you
Yeah, Haskell doesn't do like what you said, I guess.
mean? No. That's show.
Yeah, but we are
That's
inheriting.
converting to a string.
Yeah, but we are inheriting
Now print
show.
that. No, but
Oh, you mean the
yeah, we should
print
print.
function?
Yeah, so print in Haskell. Like he
Uh,
will remove the things of the string.
unless you added
What?
them. No, but unless you add them, this works.
No, but printing with the string? Why does this give you the quote still? Um, wait, what is print? And why is that, how is that different from like put, str, and len and such? Ah, oh, print already does the choose string and then it does the put, right?
Oh, now it does what we want. Okay.
What the fuck? Why does the print puts the quote? What the fuck, dude? So the print does the show, add quotes, and then prints. And then just like put str. The fuck?
Okay.
Wait, what were you using there? Wait, you were doing print there.
This is what it should be. Not. I was doing print show value, man. I was adding the quotes artificially, exactly as as we were doing there.
Okay, so
Now we're talking.
so let me look at the code. You are doing is
What I was doing this, man. But that is adding extra quotes, right?
yeah,
So that should be
because
like this.
like print you already do the show. But do again in JCI like print and a string. Yeah, but that should not have quotes. I think what we need is the put strln and show the value.
Yeah, but that is equivalent. H-Lin said that this.
And now do a
Is
string.
equivalent to this.
Oh. Oh shit. I see. Because the print will do show for everything, including if it's a string.
Yes.
Dude. Uh, yeah. Yeah, okay. So the following now. Uh, yeah. So they are equivalent. But then if X is a string, then you are adding the quotes.
Yes.
Right?
Yes.
Yeah, so that's not what we want, I guess. Like, because for example, if I'm in a language and I want like print and a string, I don't want the quotes to appear.
I don't know. I kind of want to have them to appear.
No, you don't. Do you know why? Because suppose you are in a Python program and you are printing like a menu that should not have quotes. It should just put the characters in the terminal.
No, but then you don't do this. You do this.
You see, but then they are two different behaviors. When it's a string and when it's not a string. No, but what we change is the show, right?
Yeah, if
I
you
think
add the
that the
show.
only thing we need to think is the how we are doing the show for a string value, right?
Yes.
Yeah, so let's change that.
No, but we already changed it. It's already working.
We are not even printing a string. How do you know it's
Oh,
working?
you mean printing a string? Okay, let's do that then.
Wait, do we have strings?
Yes, of course.
Oh, it's not of course.
Oh, it is, of course. What you talking about?
Uh,
Test. Do you have strings?
not necessarily. Yeah, you see, it has the quotes. It shouldn't.
Well,
Yes.
to change that is easy. You just go to types, then you go to literals, then you go to this show here. Oh, I am adding the quotes myself. You see here?
Oh shit, because of the value, because the value needs to have the quotes. Okay, so we cannot change there.
No. It's not
We
because
need
of no. It is not because that the
no,
value
it is
needs.
because of the REPL. Because in the REPL, if you give us a string, the shows for it needs to have a quote. But if it's printing, then it doesn't.
I don't
Then we
think
need to
those
change
things
in
are
the print.
related at all, man.
They are.
I
Because
don't
take
think
a
so.
look. That's the show for a string, right?
Yeah.
So yeah, if you are using the show in the REPL, because you use that to show to the user what like value it got, it needs to have the quote, you
But we
agree?
are not doing show for inner repo, man.
Well, we are, because eval returns a value and then you show that.
No, I'm not doing that.
Of course you do.
Can you give me an example where you think I need
Yeah,
to show?
go to the REPL, like our REPL.
But our wrapper is broken. You can't go there.
Okay, okay, but before that, if you went to the REPL and type a string, it will return you or it should you with a quote. Or
No,
you
it
can do
wouldn't.
in
It wouldn't.
GHCI.
It wouldn't.
It wouldn't,
It
so it
wouldn't.
would be wrong. And of course it would, because you have the quotes there in the show.
Uh, no, I actually didn't test specifically with our strings in the repo. I test other stuff. And the other stuff we're not using quotes.
Yeah, but that's the thing. I think the show is already correct. For the REPL, we need that show. But the thing is, for our print, I guess we will need to match, like if it's a string or not, because then we would need to print differently. But that's pretty easy.
I kind of don't see, I want to test first the repo before doing any sort of pattern matching on that thing.
Why don't you test the REPL of Haskell? Because, well,
Okay.
that's kind of the behavior we want. Like, it's just a string. Now do a put str on that. Yeah, that's the behavior that we want. Or print, it's like a print, but if it's a string, it's a put str. So you don't nest shows, right?
What's happening here?
Yo, folks.
Yo. 1 second, Nathan. No, but we are doing this, man.
Uh, Wait, what this has to do with
This
anything?
is the function being called in the repo that is printing stuff.
Okay, so
This is using put str.
Yeah, but there you are printing something random. Where are you printing the value?
Oh, here. This is to when you ask for the type, for example.
But where is the value per se?
The
Is
value
the
per se is calling the full execution function, which is this one, and this was using a print message, which is a put
wait.
str.
Show me the REPL part that is having the value and then printing that value. Like where
Okay,
are we calling
I can show
eval in
you
the
there.
REPL?
I can show you there. Okay, so if you are not quitting the repo and you are not asking for the type of something, which is these 3 lines, then you're gonna go to full execution, okay?
Okay.
Full execution before was this function, and this function was calling print message if everything went correctly, okay? Print message was doing put str.
Okay.
So regardless of having or not having quotes,
Wait. No. But he's doing a show on something.
yeah, that's fine. That will add quotes.
Yeah, that's what I'm talking about. So okay, this is the correct behavior that we want for the REPL. If you pass a string for the REPL, it will return you quoted, right?
Well, I wanted to test, but we broke the repo with this change.
But it's easy to see because wait, yeah, it's easy to see. So show and a string inside. You saw that you are adding the quotes in the show for a string literal.
Yes.
So then we know that the put would have like a quote as the result. Like
Yes.
you are adding that,
Yes.
right? So yeah, that's the behavior that we want for the REPL. But for the print, for the user, we don't want that.
Okay, so we're gonna have to pattern match it at some point to remove the quotes, I guess.
Well, that's our printing function, right?
That's
Uh,
yeah. Our print
it's
function, you mean the print prelude, right?
yeah, exactly. Our our print.
Let me show to Maget the thing working before though.
What
Maget.
is the show here happening? What's
No,
happening?
it is because Nathan was asking me about what happens because he noticed that when I execute this is printing stuff without quotes.
Uh huh.
And then he asked,
Oh,
okay,
with quotes, right? The
no,
test.
without quotes. The list is without quotes.
Oh,
Then he asked, okay, but how are we doing that for strings? And then I put a test here, and then he explained to me that the behavior of printing stuff in the REPL is different than in the executable.
Okay.
And then in order to fix that, we're gonna have to change eventually. I don't want to do this today, but
yeah.
eventually we're gonna have to change this function here.
Uh, it sounds tricky, Lemos, but there are two different kinds of print, right? Like the print from the REPL is our program doing, and the print of someone's program, he is doing the print, right?
Yeah.
With our print
Okay,
on
so
prelude.
before I show to Maget, I want to add the stuff here.
What the fuck is that?
Oh, this is our Emacs Lisp mode for Silverware.
How do I execute this
Oh,
again? Is Ctrl X H,
And
then eval,
yeah, buffer.
eval, buffer.
Yeah, I made a key binding for that already.
Oh, Ctrl C, Ctrl E. Okay, thanks for that. Okay, so then I need to kill the buffers that I have open with Silverware, right? Mageto?
Well, you just need to reload the mode.
Oh, okay.
Like
So,
just disable and
Silverware
enable again.
mode. Okay,
Yeah, it's there.
we need to change the colors at some point. But look at this, Mageto. Look at this code. Can you understand what's happening there?
So let me see. So there's an ABC that it takes a function, an integer, out returns, right? An integer. That's our return. Oh no,
No,
it's
this
a
is just
y.
we
It
removed the
doesn't have a
return.
return.
Remove the
Yeah,
return.
okay. Wait, you removed or it is still optional?
No, we
Like-
removed because what was the argument again?
oh wait. There are some things different ones. We removed from the AST, but we should add on the parsing.
Wait, but that was what was done before.
No, it was not.
It was.
Because no, the node that you have, it's a definition of a name in the expression. The expression would be a
No,
lambda.
you're right. You are right, but I am also right because we were doing that in the parser.
But you were duplicating the thing, right?
Yeah,
Yes,
we
we
were
were.
duplicating, but this needs to be there then.
Yeah, but we will parse the
Yeah.
return, just not put in the thing, right?
So this, and instead of nothing, you put
Literally just the line.
return type. And then you do
Okay, you're
this.
just returning nothing.
Yeah. And then you can go here, and now you can add list integer.
Beautiful. I love
Okay,
it.
go.
I would need to add highlighting to lists as
And
well,
we
right?
need to add different colors because then you're gonna have red everything. So.
Yes.
Okay, but you can
I
continue
wasn't
reading.
expecting us to go this far. So, okay, you print something that you're calling the function, passing a lambda.
Yeah,
That will basically add
this calls
one.
two things, right? So a function and a number. So this is the function.
It just increments, right?
Yeah, I want to go with Natan's approach of transforming the operators to native functions. So this will be valid also at some point.
Wait, is that my approach?
Yeah, you suggested this.
I don't remember. If you say so, I will believe you, man.
You know what we need to do? We need to do this, man. Let me just show the vision, okay? And then you guys can
I'm scared.
think.
Yeah, you should.
So
We are live, Mageta. Like, if you show something like, how can I say?
no.
Indecent, like common lisp or something,
No,
you should not show that to our.
well, depends on what is indecent. What is indecent for you?
Like, it should be like 18 plus.
No, let me
Like common lisp.
let me show good environment, okay? What is the wait? Where's Discord? Share my screen here. Can you see? Commander will cringe, but I don't care.
Wait.
I can see.
Let me cringe. I wanna cringe.
Closure.
Can you increase that font a little bit?
Yes.
That's great.
So is that some tooling that you're talking about?
Yes. We need this mode, man. We need this.
What is this mode?
This is closure, and he used to define.
Oopsie. Sorry. Thank you. Defend.
What the heck is
Look,
that?
we evolve, and it shows there.
That's
Ctrl-C,
not the,
Ctrl-C,
Yeah, but that's
compile.
that's not a
alias
language thing.
No, I'm saying no. It's not the language, I know. But like, we need integration. We need the REPL. We need to integrate REPL with Vmax. So I'm just giving the vision, okay?
Oh,
so we
no,
start
but
thinking
when
of
you
this.
achieve that, you're
You
gonna
sure
be done
that's
for
LSP
life.
labs? Is it something else?
No, we need the LSP as well. So I'm just like saying here, we should make efforts to have all of these environments. You see?
That comment that we cringe. Now I get it.
So you see my point. Like, we should strive into making a good environment for the language. That's what I'm saying.
No, but we will.
Yeah.
We're
Later
doing
on,
step by step.
later on, we can do a package manager as well. But that's just for the
A
future.
package manager? What you're talking about?
Well, we can have more. Once we have modules, we can have package manager, right?
Dude.
No. First, okay, guys. Like, let's be real here. First, we will need to bootstrap the language, right? So we need to write the compile.
Okay,
You're
come
not
on, man.
serious, man.
Now you're going in like crazy mode.
There's no way we're gonna bootstrap this, I guess.
No, man. Like, we need the JIT. We need WebAssembly, right?
Yeah, sure.
That he says sure, of course.
No, think about this. We can segregate each one of us to do one part of the thing, right?
Of
like
course we can, like, each one spends like a year on its project, and then we like...
Exactly. Like, for example, think of let's pick Commander. Commander could as well do the macro building, right? So he does that in Haskell. He will love it. Nathan does in Haskell again the WebAssembly compiler, right?
With the JIT, of course, right?
Yes, of course. You do like even with OpenGL, like WebGL, right? You
Wait,
do
what?
everything WebGL, like OpenGL
What
for the
this has
web.
to do with the compiler?
No, you need you do a module or something like this. That's what I'm saying.
Oh, like standard library, right?
Yes, you do like embedded on the standard library and such.
Oh, that would be nice.
And then I do the mode for Emacs with the repo and everything. LSP.
I already have the envision of how we're gonna make multiple files already in the parser level.
Okay.
Uh,
Wait, the parser level?
yeah, I think I already know how we can
Parser
make a function.
doesn't. The parser, man, the parser will not grow more than like parsing one file.
Dude,
No, it will. It will have
one
files.
thing. No, but
No,
seriously
it will not.
speaking now. But seriously speaking now, I think we should revisit the Lisp idea of this.
But this is
Because
not
Yeah,
Lisp, man. Aside from the S
no,
expressions.
I know. That's why. That's why I'm
it's
saying
not
like
even used as expressions properly.
yes, exactly. That is the point. So I was doing the thing with Commander. I was thinking there's a lot of stuff we can just add, and we can get some compromises somewhere. But then we get some other benefits like meta programming.
Yeah, I
Yeah,
want to
that's
see.
just changing the syntax.
Yeah, I
Yeah.
want to see exactly where are we not using the S expressions properly, aside from declaring.
Well,
For
the
example-
column there.
Oh, but that's what I
What
said.
do you think
Aside from
about that?
declaring stuff, that's what I said, right?
No, but for example, what is this? This is not an abstraction of a list, right?
No, where? You mean
Like,
this?
yeah, this S expression. This is not really an S expression. This is not a list of things, right? Of symbols.
Yeah,
So,
but
In part is
declarations
special,
we're
you
not
mean, right?
following S expressions. I agree.
so that is the idea. Like, if once we have the list into I think our node or not on our main node without being a thing that we evaluate. Gotta think on that. I'm just like saying here anything here. We can start thinking of like adding stuff like to stop evaluation and do things like this.
Yeah, maybe following more strictly the S
Adding
expression
symbols.
behavior. Maybe it's gonna get easier to do the macro
Like
later.
right now we
Yeah.
don't have symbols, for example.
Yeah, we don't have symbols yet.
What we need? We don't need symbols. We have we will have ADTs.
That's
No, but
fair.
like for example, integer. Like integer should be a symbol, right? Or if you don't eval.
I don't know what you're talking about.
Well, if you do a quote there, integer becomes is not a type anymore. It's a symbol.
Yeah, but what's the use case of symbols if you have
No,
ADTs? That's the question.
if by
Meta programming.
no, wait, Mageta. Man, I think yeah, depend on what you mean by symbol. It's a different thing than a quoted expression. If you mean symbol like in the double column something, that's a different thing.
Wait, in a what? Sorry.
Yeah, so let's suppose you have two different things. You have an expression that is quoted, so it's just an expression that is not evaluated, right?
Yeah.
Let's suppose you just wrap with a node called quote or something.
Can you do on Emacs? Let us type a meta x
Meta X
ei elm.
EIL.
No, elm like elm. No, with I on the beginning. I elm. Like Elm of Sesame Village. Yes.
What the heck is this?
Get this.
So yes, just do a quote and then plus 1 2. No, like in a list, right?
No, in a expression.
No. Quote,
Quote,
then list.
list.
No, like in Lisp, right?
Oh,
Not in
sorry.
Silverware. And then do another list, I don't know.
List.
And then plus 1 2. And then 3. No, after, outside this. Yes, like this. So run. Okay, I don't know why it dented that way, but anyway. So this is a thing with like symbols, right? So
And by the way, I think that quote 1 will be 1, not quote 1.
quote 1 will be 1. What do you mean?
I think just type quote 1.
Oh, of the form.
Yeah, it will be 1.
Oh, so it is a little bit inconsistent. Some things can't be symbols.
Type,
Magenta.
Numbers can't be symbols.
Yeah, okay.
So
okay, makes sense.
Magenta, the thing that I understand by symbol when you talk symbol, it's the thing that is like double colon and then a name, like you have in Erlang, Elixir, and as
Yes,
you
that
use those
that
keywords in.
yes, that's it. But also more stuff, right? It's like the plus there. That's also a symbol.
Yeah, what I mean is that we don't need that use case. Like,
Yes.
if you can represent symbols as ADTs, why would you need a symbol?
For example, do back quote levels, and
How do
then
you,
the same
you
thing
represent
before.
all the words in the code as ADT?
Wait, right? What?
Do you represent all the words in the code as ADTs?
Wait, I cannot hear you properly. Let me
I
increase
couldn't
the
hear
volume.
you ask something like, how can you
How
represent something as ADTs? That's what I'm not getting.
I
All the
represent every
words in the code.
yeah all the words in the code they will be ADTs. That's what he's asking.
Well, you can't because it's not dynamic, right? Like, you need to have a type for the thing. So if it's not a
Lemos
string, you
meta p
cannot. Like, you would need to define its type with all the words.
meta p twice, Lemos. Okay, wipe the comma and put a back quote and put a comma before the plus and the yes this. No, a comma.
Oh, sorry.
Yes. So like, what can we do to move this? That's my point.
Yeah, I don't see how ADTs can mimic this behavior, Nathan.
No, no, because
This
we're
is like
talking about different things, Lemos. This here that Maggot is showing, it's all regarding like quoting and evaluating and stuff.
yeah, if this is like a
Like the symbols that
previous
I'm talking
before
about, it's
evaluating.
a different thing.
I'm not talking about the Erlang atom. That's different.
Oh, okay. So yeah, that's what I was talking about, those atoms, right? So yeah, the code part, well, you just can add in the language.
Yeah,
Okay,
that's fine.
but
We can add
then
that.
in our okay, but then we would need to do another evaluator that evaluates things before, right? Which is the macro
Yeah,
expansion
I think it's
part.
gonna be an intermediate step between the evaluator and the
Not
type
not
check.
intermediate, right? Before.
Yeah, no, intermediate because I think we're gonna type check first, and then we're gonna do a macro evaluator, and then evaluator for real.
No, no, no.
Or
Wait.
do we type check, run the macro, then type check again, and then do the thing? I don't know.
Do we need 2 steps?
Well, I know that type check needs to be made like, well, maybe I'm not sure. Like, I'm thinking that the type check needs to be made after the expansion to see if it is
Yes.
generating valid code. But then I would ask, if you are type checking in some way, the macro part, would that guarantees that the result will type check? I don't think so, right?
No.
Yeah.
I don't think so.
So the question is, would you need to type check before the macro expansion also? Because after we know you do.
Okay, so maybe we need to do type checking and then replace the macros, like
Yeah,
a
expand,
pre-step eval.
then eval, then type check again. No, sorry, type check and then eval.
Yes. So you need to do, yeah, so it's something that goes before, between parsing and type checking goes all the macro stuff. Yeah, that can work. Yeah, anyway, so yeah, but now we have declarations. We just need to do the definition of values at the moment now.
Oh, do a declaration. Can I? Oh, can you show that back again? I
Yeah,
didn't pay much attention to
yeah,
the ABC. Yeah, that's cool. We have
yes,
lets, we have the funs.
yeah. So,
How did you change the scope by the way with the state monad? Poor
oh
state
no, we
monad.
don't need that because Nathan had we followed Nathan's plan.
Magenta, maybe you only need to type check twice the macro expansion, right?
Type check twice.
Yeah,
The
we don't need
macro.
to type check twice the whole thing. Like,
But why do we need to type check twice? In my mind, we just need to type check after expansion.
Yeah, like it kind of makes
Because
sense, right?
if you are doing
Because
expansion, you would be executing code that is not type checked, right?
yeah, okay, like yeah, it makes sense. Like you can
Dude, I
add
think
two
we need
things that
a
are
proof of concept. Like, we need to do a tiny language with just these and not all the other complex stuff to see how the things work.
yeah. That's what I'm doing. Like I wasn't thinking of being a tiny language. It was just to learn Common Lisp, but we're doing that.
Yeah, no, but that makes sense now that you said it. So because we are executing code in the
Yeah, like
expansion
for example, the
itself,
plus there that you ran on the eDisp.
yeah, so it's gonna
Magenta,
be
but it's
like,
a different thing than you are doing because, well, we will not need to add all the complex stuff, but we need at least a type system
No,
of like
we're gonna add a type system, man. Wait.
really?
Oh, I didn't know that was the
Commander
intention.
will help you make that?
Yeah, why not, man?
Uh,
That's unexpected.
yeah, I was not expecting that at all.
We're just gonna add a normie type system, and probably we will.
Why don't you do
Probably.
a optional one?
Oh
Everything can be a maybe, basically.
No, no,
no,
no, that's
everything is
not
one
what I
type
mean.
actually.
Like, it's
Like
optional if you
enabling.
will type check or not your program before running.
Oh, you
Yeah,
have the
yeah.
crazy mode all the time. Okay, that's fair.
Crazy mode, man.
Yeah, that's what
Crazy
I
mode.
told you back in.
Dude, I really do want to just press Ctrl X, oh, or Ctrl C, and evaluate just that part of Silverware. See what I mean?
Yeah, that would be crazy when we managed to do that with the Max.
But Lemus, is there something like major that we could do right now? Like, that
Yeah, we
would,
can do the def values.
Oh, by the way, Lemus, do this, man.
wait, without being parsing, because,
Dude, Lemus, do
Okay,
this, do
go
this.
again.
Go back there. Click on the thing. Do Meta Shift 7.
Meta shifts. Wait, too many buttons. Meta shift 7.
Type async shell command, yes, and then run the stack thing. Oh, but in the file, right? You look at the folder you are.
No, I'm assuming we are on the Spatula folder.
You are in the phone. You are inside the examples folder. So you need
Okay,
to
so
go
I need
back
to
twice, I
change.
think.
Let's go to, I don't know, here. So async shell
Command, and then you run. Oh,
is.
okay. And can you just start the REPL instead? Just start the REPL.
Start the repo.
just because you want to see the thing being
No,
printed
no, no.
there.
Like the Silverware REPL. That's what I mean.
We don't have the Silverware repo because,
What?
yeah, because I had to nuke it because we changed
Oh no.
fundamentally how it works with declarations. I need to redo it.
Yeah, we can
Oh, I
redo that
see.
now, right?
Yeah, we can.
Yeah,
Lemus, just
because
put the
here's the thing.
annotation somewhere.
No, wait,
We
Magetta finish,
No,
please.
because what I'm saying is we can just. I already know how to do this integrated with Emacs. We just do an inferior mode and define the command that runs asynchronously, and it does exactly that. So we can already evolve Silverware code interactively
Wait,
on the REPL.
can you just do Ctrl C?
Yes, and send the code. Yes.
Oh no, but that will not work because assignments don't work on the repo yet. I need to make that
Well,
happen.
yes, but once we fix it, we can just make these commands and then send the code there, and then we already have the mode, man. We just need the LSP.
That would be crazy, Chao. We can do
Uh,
we can finish Nathan we can fix the repo, yes.
Let's
yeah,
do it,
but
man.
that's not only it. We need the annotation somewhere to change the listing. Uh, if you
Wait,
remember,
what you're talking about?
ah, t- 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 t-
Dude, one
so,
thing I was thinking, just before Nathan goes, can we expose? Oh man, I think it would be too hard to expose, like extern in C, something like this, to expose stuff so we can make a bindings in another
yeah,
language
you
to
want
communicate with Haskell.
interrupt.
Yes. Do you know how to do that, Lemus?
I
Like
don't
to
think we.
call Haskell modules from another language, like making an
Uh,
API.
I don't, but I'm willing to learn it.
Because we could do in bindings for the language, right? So we just do okay eval compile, something like this, and we can extend the, like, I don't know, do the repo in, I don't know, Rust or something like this.
Well, I'm sure there is a way of doing some sort of interop.
Calling Haskell from C Sharp, I'm gonna do the repo in C Sharp.
Cursed.
uh, I will research about it. But anyway, go
Yeah,
on.
okay, anyway, sorry for interrupting.
Go to the expression IDT. Yeah, go to the type. Well, actually, it's a type. It's not the expression.
You mean this one?
Yeah. Go to the list one. Right, and we need to put a comment above that.
Okay.
Because.
What is the comment?
Oh, yeah. I still need to think because so far we cannot pass like a list.
We didn't test it yet. That was your question last time, and I
Yeah,
didn't
so
answer.
let's do it because I'm pretty sure we can't.
Test if you can pass the type of the list to something. Okay, so I didn't recall. The reason why I didn't answer last time is because now that I think about it, it's because we don't know how to parse that. That's why.
Yeah, and now we don't have a record to
No, wait. We do have a parser for the type list. We do have one.
No, but that's list applied to something already.
Yes.
Yeah, we need only list, like just list.
Well, but I think we discussed this with Magetta back in the day about not allowing you to do that.
Sorry, what?
Yeah.
The thing.
Do you
So
remember?
then how can you?
Go on.
Yeah, so how can you abstract over the type list then?
You can't
You
right now.
can't. Yeah, that's a huge deal, isn't it?
No, I agree it's a huge deal, but it's not that we are not aware. We discussed about that.
No, then that's why the comment, because I think I know how to fix it. Maybe.
Oh, really?
Yeah?
That's cool. How do you fix it?
So we can parse list, right? And oh, okay. I think I remember one. Yeah, so I think we will need to do the type alias first, because it will be an alias that is already in the environment, right? And then it will be a function from type to type.
Wait, I'm
And
confused. Why does it need to be already in the environment? Can't you just introduce a type variable and call it a day?
No, because a type variable is different from a type alias.
No. I know, but why it needs to be a type alias?
Because, okay, the type variable is limited in the sense that it is abstract. So you cannot really compare it, right? So how can I explain? Uh, uh, Dude, I don't know how to explain that well right now.
Wait. You can compare type variables. You just need to look at its kind. If it's the same, you're good.
No, that's the thing. You can only compare with itself. But that's not the case for type alias. You can
But
compare type alias with something else, and this something
no,
else.
man. Look at this. This is used for type variables, if I'm not mistaken.
What I what I mean by you can compare, I mean it will only be equal to itself, and that's not what we want.
No, but that's what I'm saying that it's not. I just need to make sure that I'm not saying crap. One sec.
Dude, I can do
Yeah,
that in
if you
SP.
go to the equality of types, you will see that the type variable is only equal to itself.
Let's go to there. So equality of types.
Yep.
No, this is the show. No, the equal we are deriving. So we need to see the equal of the t variable
Oh,
info. The
it's
equal of
derived, right?
it is also derived.
So yeah.
Okay, but we could change this, right?
No. We can't. That's how type variables work.
Oh no, I am confusing the t variable with the t for all. Never mind.
Yeah. So yeah, suppose we have already type alias in place, and then we can introduce a type alias in our prelude, right?
Yeah.
And the type alias would receive a type, right? And would return this type inside our type list, right?
Mm-hmm.
So then our list would still be, how can I say, would still have the limitations that it has, like the user cannot define it, because you would need like recursive types. The other limitation is regarding type inference, but that's not really a problem, not really a limitation. But yeah, the user would be able to pass the type list to something or to applying something like normally.
Mm-hmm.
Yeah, so let's just do a notation for that. If you go to the data type and go to the t list, you just put something like, oh, when type alias are added, we should include. No, but it is. Well, that's okay. We should include type alias for list that returns the t list, I guess. It's not generic list type.
Yeah,
It's
the list t
literally.
is generic.
No, it is not, because it's not a maybe, right? Wait, are you using the maybe still?
Yeah, we are still using the maybe.
Uh, it's not generic. If you are passing something, it will always have this something. Like, it's always concrete.
Well, it is generic in the type sense, right? But okay.
Well, yeah, the alias is generic, yes, if you take a time.
Okay.
Yeah, I think that's it. So let's try to do real fast
Oh,
fix the repo.
I don't know if that's
dude,
gonna be fast.
I,
Go
I don't
ahead.
want to interrupt. I don't want to interrupt, but
No,
I'm
go.
just looking here. You can just do the extern on like Haskell stuff, and then you can do in like I don't know C sharp, and then that implies you can
Wait,
do in
wait, wait, wait.
yeah.
Anything?
Yes, like
Not
you
with
make a
C.
C yes you make a C interface for that, and then you compile with GHC JHC with like some DLLs there,
Yeah.
not DLLs, souls,
Mm-hmm.
and then you can just access from like I don't know .NET, and then you do the LSP using Microsoft's LSP library.
Okay, so we do have a path for that then.
Yes, dude, I think I'll try this. We can even interface with Go, and then Victor would
Just
write
to
in
make
like one.
Victor happy.
Yes,
But I think you guys are forgetting something. Just because the language have the FFI in place doesn't mean that it's easy to implement ours.
Yeah, that I agree.
just because the language has the what?
The interop doesn't mean that we can implement ours like easily.
We can implement ours easily.
Yeah, for our language, right?
Our interop, you mean? No, no, dude. I'm
Yeah,
talking
like
about
you using
no,
a
no. The
fun.
interop that I'm saying is the parser, for example. Like
What?
we just parse the thing and yield something that is like translatable. You see, to another
You
thing. I
don't?
just
Wait, can you
like
give an example, like a
what do we
concrete
need?
example?
For example, what do we need for the uh, what do we need for the completion, auto completion? We need the
What?
parse. Like LSP, think of LSP. What do we need for LSP?
We need the
Okay.
We need
parser
the
to be
parse to
externable.
have a tree, and then we can infer stuff, right? Infer in the
Okay.
sense of, okay, if the user here is typing blah blah blah, that was defined
What
like
is
two
the
lines
type
above.
of that, right?
Yeah, what is the type? Also, we need both the type checker in our case, right?
Yeah.
And the parser,
Okay.
which is in Haskell. So what I wanted to do is translate this garbage from Haskell to another language that we have the LSP support to, like JSON RPC and everything, with the types from JSON and all that crap. So we can
I,
just
I'm, I'm, I'm losing you. I don't know what you mean translate.
What he wants is picks some parts of the Haskell code translates that to another language that has all the environment and the infrastructure to do other stuff.
Okay,
Yeah,
so you want to pick a program in Go and use our parser in Haskell to parse our language?
yes, but then I think it will be a problem on the Haskell types, right? I don't know if he converts everything to like a
Yeah, I know
struct or
nothing about
something.
this stuff, so I can't
So
help.
maybe we would
But
need to do some Haskell stuff to do inference
wait,
on the
Magita,
completion, but
weren't you
whatever.
talk about adding the extern in our language?
No, I'm
No,
talking. No,
that's
Oh,
I was saying on
okay.
the Haskell to do that.
Oh,
In our
okay.
language, it would be cool as well, but I think
Yeah, that would be very, very different.
yeah, that would be a totally different discussion, Nathan, if that's the case. But that's not the case.
yeah, I think we're very far from that
Yeah,
actually.
we're very far. Let me think how to fix this crap. One sec.
Oh, we could write our own in PHP. What do you think, Nata?
Lovely.
Ruby, dude, Ruby. We're doing Ruby, Nata.
Oh, yeah.
Both of us.
I don't know about you
Ah,
guys. I didn't like Ruby that much when I learned it.
I hate Ruby.
but
Anyway,
No,
wait,
but you
what do you
hate
have?
everything that has a bad community, Market. That's not
no.
surprising. So
Well, bad community is just guys that are saying, right? It doesn't mean much
no, no, no.
the
Yeah,
I
but
am
real.
just copy pasting what Namageta says all the time.
copy pasting.
I'm
Oh,
not
dude,
necessarily saying it is.
there's for Java as well. We could do enclosure, Scala. Oh, dude, an LSP enclosure would be so easy peasy. Oh man, it has docs, dude. Oh man, like the only thing I envy Java people like in comparison to .NET, because I still prefer .NET in the end, is that they have docs. Like their docs is not like Microsoft level documentation.
I
Wait,
see
what the
what you
fuck
mean.
is that get type, man?
Yeah,
Just a moment. Let me think.
Why is parameterizing over a parser? Oh, fuck? Like, don't you want help with that?
Don't you want what?
Don't you want help with that?
Oh, you can help me, but I'm doing. Okay, let me explain what this function does. Because if you type this on the or this in our repo, it will give you the type of the thing.
Yeah.
But we just changed that.
We just changed that? What do you mean? It
Um,
should still work the same. That, like, needs to be an expression necessarily. You don't have a type for declaration.
yeah, so this needs to be expression. So this can
My
be like
first
that.
question is, why does get type receives a parser?
Because I was thinking about making it generic when I did it, basically. But you're
I
right. This
see.
always needs to be an expression parser.
I guess it's the first time that like Lemos didn't remove the type for the
Oh
No,
man,
when I don't do the type, it's because I know it's gonna get like rusty, very hard to deduce by myself. Uh,
deduce.
deduce.
yeah.
Like the type checker knows.
No,
Why
no.
don't you
In the
copy
repo,
paste?
I can ask, but I didn't do that. Type check expression. How is going the database project, by the way, Magit?
Oh, I'm gonna start. We're doing the language in Common Lisp to like get to know the language actually.
How is the language going?
Well, we're suffering, but it was more because of the library.
That's
Like,
fair.
dude,
No,
it was really pleasant to do the thing. No, really, like, dude, I was doing I think
Okay.
yesterday, 2 days ago with Commander
I
the.
believe you found pleasant, but I would not believe it's pleasant like in general.
Wait,
Like
what?
for
And here's the thing. Instead of LFA, that I could tell the code was not safe, I could see the code, well, safe in the sense of what you can do, because we still have types in Common Lisp. Like, you can still have a certain level of safety on that regard.
what do
But,
you mean?
well, you have types. Like,
It has types. It's just
you can do
it's all
static
hidden,
annotation.
Nathan, basically.
Wait, you mean the sense of type off?
Uh, What do you mean type of?
Like type of, like in JavaScript
I
or
don't know what
C
you mean.
sharp or F sharp for that matter.
What do you mean on that, man?
Like dynamic language, you
Okay.
can ask for the type of
No,
something,
you have
and
static
then you
typing.
check. You
You
have
have
static
static.
typing
Yes, you do.
in Common Lisp.
In Steelbank Common Lisp, static typing. Let me
Yeah, you
find
do
it
have
here.
static typing, but it's like I said, it's very hidden. You need to ask for the
And
all
one
the
thing,
time.
it's a different, and you gotta think that it's a weird language as well. But you do have static typing. It's like not types, for example, like
Interesting.
for example, the new is a list, so you gotta think of that when you're doing the.
But the important thing is, you don't need to execute your code to check stuff.
Yes, exactly. So
Yeah.
you can do
Oh,
that.
and that's okay.
Yes, that's the benefit, I would say. Like you basically need to modify one tiny part. You don't need to compile all the things. So you remove all bureaucracy. You just have like
You're right,
one
Nathan.
tiny part.
I'm writing one.
It
Okay,
is
it
very fast
works.
to fix the
Well,
repo.
first of all, of course I'm right, but writing one.
Of course I'm right. Did discuss?
It is very fast to write the
Oh,
fix the
dude,
repo.
just leave the spoon there, man. The knife and the thing. I don't like that.
No, I will not remove the lambda. No, I can remove the knife though.
Wait, but what was the thing that you changed? Like, what was different? Because
No,
I think you're lacking stuff, Lemos.
no, I'm not. What I did is that I figured out in my dummy head that if you're doing the repo, you don't need the declaration crap. You can just use the
You do,
expression stuff.
you want declaration, dude.
Do we want to have that fun in here?
Of course we want. We
Don't
want.
we want to have like I don't know a name equal?
Well, that's something outside the language. Why would you want outside the language stuff?
Oh man, it's gonna be so verbose, but okay.
Wow, that's the
Okay,
language.
now you know what
How
to do,
would you
right?
write in the REPL something that is not the language?
Now you know what to do, Lemos. You start the REPL from Emacs.
Oh yeah, now we can do that. Okay, so
Oh,
how
yeah.
do I do that? Sync?
Yes.
No, but I need to be in the correct
The
crap.
meta P.
So
Yeah, there it works.
no, that does not
Okay,
work.
in
I'm
the
not in
root,
Spatula.
yes. Meta
Okay, my
P. Oh,
LSP of Nix is broken. I don't care.
Oh,
LSP
Magenta,
is
but did you
fixed.
manage to
Meta
finish
P.
the parser?
Meta P. Oh, dude, we're gonna use parser combinators, I think. Meta P. Just Meta
Yeah,
P.
correct, not the.
Look at.
Just Meta
It's
P.
not good. It just means they will not be able to use it.
Dude, it is so much easier. Like, there's no comparison. Like, to have to translate their AST, it is worse. Like, it is much worse. Okay, dude, Lemos, just Meta P, man.
Again?
Yes. Stack REPL, we start the stack rep. Okay, you ran stack REPL last time. Do the spatula REPL. That's what I
Okay.
mean. I thought you had run it, but no.
This.
Yes, okay. Yes.
Not found on
Okay.
path. That's great.
Okay, you are running on the shell, on the root, right?
Yes, I am
Oh,
running on
did
the
you add the spot? Don't you need to add exec? Like
Didn't
spatula
we do
exec?
that? Oh,
No, you
XZ!
didn't.
I didn't.
Yes.
Sorry.
Yeah.
Okay, so
Just kill
this.
that. Just kill the buffer.
It
You're
will ask
spawning
again,
it.
that's fine.
Yeah.
Exec, spatula, this. Yes.
What?
Yes.
Not found.
Spatula not found. Oh, you ran spatula, not stack.
I was asking my.
Yes, look at the command.
Dude.
You're just
Stack.
spawning shells, man. Okay, now, okay. There it is. So, open a Silverware file on the left. Yeah, so
No,
right
but that
now,
will not work because if we throw the
yes.
code there, because the REPL doesn't know how to tackle that, then we're gonna
So
be
we
doomed for
can,
life.
yeah,
Yeah,
so
but
here's
that's
the,
just our fault, right?
yeah, but here's the thing. We just integrate and make a mode, a minor mode that is like, I don't know, Silverware, how we're gonna call the REPL system. Like in Clojure, it's cider, I don't know.
Why
the
don't
beverage.
just repo, man?
Why not
No,
fork?
man.
We have the spoon, we have the knife. Finally, have a fork.
Why not?
Well,
Like,
wait,
because think
folks,
about this, like,
repos usually don't have names.
no, they do. Like in common Lisp, it's the SLI environment because
Okay,
it's not
give me
only the
another
repo.
example, like
No,
besides
no, no, no,
the
no.
list.
Wait, it's not only the repo. You're not thinking. You're thinking of only the repo. I'm talking about the mode for
Then you are
Emacs.
not naming the repo, you are naming
No,
something
dude.
else.
Yes, you're naming the environment.
I vote
Everything
for
else. The
fork just
repo.
to have the triumph. So
Man, fork is kind of boring, man.
we have knife and spoon. What are you talking about?
Spatula, silverware. Think of silverware. What would be the thing?
Oh, fork is silverware,
Bakery.
right?
What about bakery? You're baking programs.
Fuck, man.
Anyway, we can think of that.
Yeah, we're gonna have to
So
think of
anyway,
that, but that's fine. Anyway, now it's the time, Nathan, that we should fix the repo in the sense of having declarations.
let me see here how we can do the thing in Emacs to
Oh
send a
man,
command.
I
this
think I
way,
have to
this
go
way
now,
of
man.
this way of grabbing if the guy typed the column T is so much fancier than last time. I get you don't understand. But
The
anyway,
wait, the column queue.
yeah, the column type and column T because they are because here I'm just saying, oh, if you type
Oh,
those, I'm gonna
okay.
finish the repo. But here I'm saying if you typed in the beginning of that one of these two, you need to go to the get type function. We did last time in a very dumbier way than
Oh
this.
yeah, we're just yeah. I remember.
This is so much
Wait,
fancier.
Lemus, but let's try to just like show me the overview of the thing and see if I can like maybe help with something
Sure.
because I will need to leave in a few minutes.
Oh yeah, you have half an hour. Yeah.
Uh,
Oh yeah, you need
an
to eat
hour?
something. So in less than half an hour, I guess.
I will not.
Uh, okay,
Okay,
so
the repo.
okay, the wrapper is really easy. Ignore this part because this is basically doing a transformer. Just focus on the insertion function.
Okay.
This is grabbing, this is printing this, and getting the input that the user is typing after. And then we call
Okay.
this min input. If you put nothing, if you type nothing and just press enter, you're just gonna clean the repo and call the function insertion again. So it's gonna do nothing basically.
Like if it's not the commons,
Yeah, it's this.
do sure, but let's see the other part. Like
Yeah.
if it's the commons, you do the commons. If
Yeah,
it's
if it's a
not,
command, I first clean the thing. If you ask to quit, we just quit. And if you actually ask for the type, we do the type. We do the
yeah,
get type.
I'm trusting you that in get type you already like, oh, if it's not an expression, I will fail, right?
If it's not an expression, I will fail. That is happening.
Okay, so let's go to the full execution part.
Yeah, if you don't press like Q or like column Q or column T, then we just go to full execution, which will parse
Yeah.
the thing. If it encounters an
Yeah,
error.
it's not a file, right? We don't have like multiple lines, do we?
We don't have multiple lines. We can Haskell has that support, and Common Lisp as well, to have multiple lines.
Yeah, but they use like some special stuff, etc. Like, can we do that right now? I
In
think we
Haskell,
can,
it
right?
has special stuff. You need to use special syntax, but in Common Lisp, as far as I can tell, you just copy paste and go.
Yeah, let's do the declaration for now. Right, would that work by default? Like just we using file PIDA?
It will. I
I
am
think
not
it
sure.
will. I think it will, yeah. We can just deal with the list. If it's only one, that...
Okay, it is working.
Wait, that's not... Yeah, that's not quite when I'm asking.
No, but it is working. It's not working correctly, but it is not like breaking.
Yeah.
So the def
Yeah,
fun
so
and the expressions
let's
work.
try with the whole file. I guess it can work. So what we do is we parse it,
Yeah.
sure,
If
and
we
if
have
it's
an error, we
okay,
print the error.
we have declarations, right?
Yeah.
Yeah, now it's the important part.
If you have declarations, then we're gonna type check those, using
Uh,
the function that we made.
okay.
And then
That one, right?
this is using the wrong name because this is type env actually.
Yeah, that's very important in the case of the repo. That's very important.
Yeah. So if you have a type env, then we're gonna check if you have an error doing the type checking
Oh,
of the things. If you had, then we're just gonna do the show print that. If you
Okay.
didn't, then this is gonna be, I don't know, prime, and this is gonna be type environment. This.
Okay. And then we just evaluate, right?
Yeah, then we pick the type environment and we ignore it.
The result there is the like evolving, right?
Yeah, this is the evolve.
Okay, then
Right.
it's very, I'd say it's very easy, but then it's clear what we have to do. You see that we are getting like two envs, type env and eval env. We
Yes.
need to increment that on our next like repo prompt because the things that were declared, you see?
Oh, but then we need to call recursively, I guess.
Yeah, and maybe there is more than one problem, man.
There's a problem though. I already can figure out the problem. If the
What is it?
functions that get us the type checking and the evaluation, they are not getting us. They're not returning the values. They're returning the environments.
What?
Yeah. So when you eval declaration, what is the return type of that? The return will be an environment.
Sure.
That's bad
Like,
because we want to show the user the evaluation of that.
oh, I see, I
We
see, I
need the
see, I see.
tuple that you mentioned.
Wait. The first thing is, we know that you already have the env, so then the next prompts will have those things in the env, right? So that's okay, we just need to call recursively somehow. But then the other problem that you said is that, okay, we also need the env, well, the value
Yeah, in both
to
cases we
print,
need the
right?
tuple. In the type check declarations and in the eval declarations.
Well, why do we need in the type check?
Because I can ask because
No,
we
no, you
don't,
don't.
because I'm doing
Yeah.
type check expression
Later,
here.
you can just do like the t command and put like the variable that was declared, right? And that way you
Yes.
get the type. But
Yes.
values, we do need to print values.
We do need to print values.
Ah,
I don't think we have a choice. We need to return a tuple at least.
yeah, I guess the thing would be instead of doing like a file, we do this just one declaration. And then we know like the behaviors that will be different, right?
Wait.
Yeah.
Okay, so
Okay.
full execution needs to have a brother called single execution, I guess.
Ah,
That instead of this,
I'm
it's gonna be single. And a single execution is always an expression P.
Yeah, maybe that works like, because the gist is we need to treat differently, right?
Yes. But there's another problem though.
Oh.
Even if we are parsing expression, a single expression, instead of a file which has multiple declarations, we only are returning one thing at a time, or we are always returning the result.
Wait. Man, we have full execution and it has declarations, right?
Yes.
But single execution receives only one declaration, right? It
Yes.
will pattern match if it's one on the other, right? Uh, and sure, if it's a declaration, he will not return a value. He will just add in the environment, right? But if it is expression, then you know that you will return something like, for example, yeah, like it will return a value because it's just one, right? And then full execution, who is receiving that stuff, he would need to collect stuff like, oh, this gave us a list of values.
I am very confused. The full
Okay.
execution for me, it behaves completely different than single execution.
It does, but single execution will be called inside full execution, right?
Why? That's what I don't understand why that's necessary.
Okay, because full execution, let's suppose we want to do the file, right? We want to do the file. Then they need to be executed in different manners, the declaration and the expression. Because for the expression, we need the value to print. Then that's why I thought you create like single execution to do a match and treat them differently.
No, I was thinking about making type instead of type check declarations and eval declarations, we would make type check declaration in singular, and then this function will return a tuple. That's what I was thinking. Because
Wait, can
then,
you say it again?
yes, if my idea when I made sequence execution as a brother a fool was to make similar functions of type check declarations and eval declarations, but just type check declaration and eval declaration, and those guys would return a tuple.
With
Then
oh, I
we
see. I
could
see the
we could
environment.
call recursively single execution inside itself here.
First of all, we don't need the type in type check declaration, right? We don't
Okay,
need
that's
like
fair.
the value stuff.
Yeah.
Um,
But the eval declaration, it would be necessary to. Oh, if we don't need, we can just do this.
wait a bit, man.
We do that. We call this
Okay, you are
this.
saying single execution is broader. Wait, you mean broader? Like sibling, or like more abrogant, like more?
Yeah, the structure is very similar. You look at this code and you
No,
look
no.
at
What I
this.
mean broader. Broader means like a sibling, or broader in the sense of not narrow.
Oh, sibling.
Oh, okay, okay. Yeah, so do you intend to use like single execution inside full execution? Is that the plan, or
No,
the
I was
otherwise?
thinking of just calling single execution in the repo function here.
Oh, then what would happen with full execution?
It would just be done if you just want to do this. Uh, Wait.
Want to
If
do
you want to
what?
do this, exec
Oh, but that's
spatula.
not the repo.
No, but that's not a repo. If you want to just interpret a file.
Yeah, but this is already made.
No, this is already made. But then the full execution will be used only on that scenario because right now it's being used twice. It's be using
Yeah,
the repo and
then
it's be
take a
using
look,
normal.
Lemos. Then your single execution would not be able to parse like a file, right? Just one declaration per
Yeah,
time.
for now, yes. If we like, if at any moment in the repo you want to do this,
Yeah, then you are discussing different stuff.
yeah,
I was thinking that we were going for let's do the file. But you are right. Like doing only one declaration is much simpler and we can like done with it like a lot faster.
exactly. So
Uh
when you
yeah.
do this, when you do that, you're gonna do print message with the result.
But wait, where are you matching the declaration? Like
Wait,
you
that's
need to match the declaration.
this. When I am matching,
Yeah,
I don't
and
need
you
to
will
match because
not
I'm parsing it.
uh,
Declaration.
uh, well, that's why you need to match. But
And then you
yeah,
print,
yeah.
and then you do
There are two
this.
things, Lemos. The
Single.
first one is you will not need the tuples with
I
like
will
result
not
and
need the
all.
tuples.
You will not. Uh,
Really?
yeah, really. And the other thing is you have to match to see what kind of declaration are you dealing with. Is it a declaration itself or an expression? If it's an expression, then you can use the eval and print it, right?
Um.
Because it will not need the eval env, because well, it will not add anything to the eval env.
Oh, you're right.
Right? If
You're
it's a
right.
declaration, then you don't need to print shit, but then you will add on the
Okay,
amps.
so you first do that, and then you say, okay, if I have a
Then
expression, if I have an expression, then I'm just gonna do uh, run do result run except t eval expression, and then I put evaluator prelude, and then I put xpr, and then I do print message result. That's it. And then I think I need to call this function recursively, I guess. No, I need to call insertion because I need to go back to the repo. Yeah. So I call insertion. So this guy is actually not an IO, but I'm going to deal with that later. If you have a declaration of a definition, Then you're gonna have a name and a body.
Let me see. Eval, result, print, and just call search again.
Yeah. But if we receive,
Well, but those need to take like some stuff there. You need to take a name that they are not taking right now, right?
yeah, right now I'm just sending the prelude to the evaluation.
No, I mean either insertion or single execution, like even both. Like they will need to receive a name, right?
Oh, you're right, man.
Of
Oh
course.
crap. Of course. I don't know what happened to you today with this. Of course. Uh,
It's a joke, man.
no, you
What
need
happened is
confidence to the
that I
interview.
am
I get.
right.
I know what you're doing. Okay, so why do we need that environment, Nathan?
Well, you go on that. I will talk to Magenta. Magenta.
Hmm?
Like we are doing the repo and we are inserting the possibility for you to do declarations in the repo. So you can bind stuff and use it later, right?
Okay.
And then the types like are in the way, basically.
That's
Okay.
a good way to put it, I would say.
So yeah, you like some stuff, some functions you need to receive the env, right? I'm not necessarily like sure on which one are the minimum set that needs that, but well, some do.
Some do need to receive the environment.
Yeah, because you know that we are using a function to like execute the things in the repo, right? This will be called like
Yes.
recursively. So this call recursively needs to receive an env, like incremented.
Oh, I see. Mm-hmm.
So at least insertion needs it, right? And since insertion is calling single execution, I guess it also needs
Yes.
it.
Yeah. So
So
this would
okay, I
be
see.
evalenv.
Can oh man, I would say can't we wrap the REPL itself inside a state monad and then we just have the env as the initial state?
Of course. That's the
And
The use
right
case
way
for
to.
it, right?
That's the right way of doing it.
okay, and what is the way we are doing?
Recursion.
Oh, okay. The
What
thing
is
that I was
that?
annotating.
But it's basically just not using syntax sugar, right?
Well, in my opinion, in the state monad would be clearer, but
No,
that's
yeah,
just
syntax sugar, right?
How do we do state monad in Haskell? That's a good question.
uh, it's very easy actually, but I'm not.
So why we're not doing
It
it?
is easy, but it's not as easy for me at the point that I can do it blindly. So
Like, it's
Okay.
easier to just do it, right?
uh, I
It's easier
am.
to just call recursively the thing, right?
Yeah,
Well,
for
it
me it's
is.
more straightforward to call recursively, but you are right. Um, wait. So
Dude, you know what I felt a genius today? I was doing the thing with Commander, and then I said, "Oh man, this is like we were like struggling with the tree." And then I just said, "Oh, let me write a code, a sketch code in F sharp, and then you see if it works." And then I wrote like some complete bullshit. I didn't even test anything. He literally translated that to Common Lisp. He ran, and then it was right. Like, and I was like, "What the heck?
well,
Of
man.
course, I
How?"
have time to time.
Okay, so Nathan, you have 10 minutes. I think we can stop now. We're already past to the time, I guess. Yeah,
You
two
I'm
guys
hours.
don't need to
making
stop, but I will.
Yeah,
I'm
I
making the
will make
mode,
the
by the
state
way.
monad correctly.
I'm making the
Okay.
mode in Emacs, by the way, so we can activate the repo and send commands to the
Oh, that's
repo.
good. That's good.
Okay,
So
so
stop the
see you
streaming now.
folks.
See
See
you,
you
Nathan.
later. Bye bye.
Bye.
Bye